Assalamualaikum and hi. My name is Nur Alia Alisha BINTI HEZRIE. My student ID is 2025180911. I will be presenting to you about assignment 2 named Bookstore Inventory.
My project is a book inventory management system built using fundamental Java concepts and 4 abstract data types. The primary goal was to create a functional system that can load book data, perform essential inventory analysis, and manage records using queue and stack logic. All of our records are initialized from the bookdata.txt file, which we process and load at startup. The entire structure is anchored by the linked list class. This forms the base for all our derived data structures, allowing us to manage records stored as book objects through flexible linked node structures. Crucially, we implemented a custom empty list exception to prevent crashes, ensuring that any attempt to pop or dequeue from an empty structure is handled gracefully, which contributes significantly to the system's stability. Now let's take a look at a book class. This is my book class. It has string book ID, string title, string author, year of publish, integer quantity, and double price. It has default constructor, normal constructor, setters, getters, and toString to display all the attributes. Now let's move to our main agenda, which is main book 2 class. Our main inventory storage and processing occurs within the queue data structure. Following the first in, first out or FIFO principle, the queue models reward inventory handling where the oldest stock should be processed first. We begin our main book 2.java by showing how the data is loaded into the queue and then displayed. Before that, I will declare a new temp named utemp to move all the data temporarily in the new queue. Once loaded, the queue facilitates key analysis requirements. By iterating through the keywords, we efficiently calculate the total stock quantity and the average price of all books. We also use this single class to identify the specific books that correspond to the minimum and maximum price, which is highest price and lowest price in our inventory, demonstrating effective data aggregation across the collection. This is the output for displaying the data. Book records, it has 5 data. And this is the output for total stock quantity and the average price. It has some average, minimum, and maximum. This is the output. After that, I will restore back all the data from the temporary queue, which is temp queue, which is qtemp, to the book queue, which is their original queue. Same goes to the total stock quantity and average price operation. I will restore back all the data in qtemp back to the book queue. Next, we move to the stack data structure, which use a last in, first out or LIFO policy. The stack is used for temporary storage and specialized inventory tasks. We will demonstrate 2 key transfer requirements, which is queue to stack move and stack to stack move. For queue to stack move, we isolate all books published after 2015 by moving them from the main queue to new stack. The main queue is book queue, and the new step is book S. This transfer allows us to quickly access the most recently published titles for separate reporting. This is the output for books published after 2015, and all the books insert in the book S tab. In addition, we has another queue to stack operation, which is low stock books that has quantity less than or equal 20. This is the output for low stock books that has quantity less than or equal 20 that move from book queue to less tab. After we make all of those operations, we will restore back all the queue that we move to the main original queue, which is book queue. Now we will move to the second key transfer requirements, which is stack to stack move. We then focus on low stock books. We will move the books from the less stack to S10 stack. Just now we move all the book from the queue to a less stack, and then move them from a less stack to a temporary stack, which named S10, and immediately back. This complex stack to stack move ensures the last in first out order is preserved, which is vital if the most recent low stock book must be addressed first for restocking. This is the output from moving the books from less stack to S stack. Finally, we will demonstrate the delete operation, a cordless function that proves the list manageability. We remove a book by its UID B004 and verify its removal by displaying the remaining records in the queue. This is the output. We remove the B004 and the remaining books we will display here. Next, we will move to our last operation, which is expression conversion from infix to postfix operation. This is a canonical example of a stack's power. This logic is implemented as a static method within our stack.java file. The process relies on operator, precedence, and straight handling of parentheses. Operands are passed directly to the output. Operators are pushed onto the stack, only being invoked when an incoming operator has equal or higher precedence. The stack is essential for temporarily storing and ordering these operations. We demonstrate this conversion with two examples showing the final postfix results. This is the output from the expression conversion. Example 1, this is example 1, and this is the example 2. And this is the postfix conversion from the infix expression. Importantly, this implementation is robust. If we input an expression with mismatched parentheses, the program correctly throws our custom empty list exception, terminating the conversion and printing an error message. This is the error message. This is all the output from all the operation that I made on the Java project. For the conclusion, I think this project successfully leveraged the core features of the linked list, queue, and stack to deliver a complete and robust inventory management system. I successfully met all required criteria, performed essential data analysis, managed complex transfers between abstract data types, and implemented robust error handling. The project demonstrates not only the implementation of these structures, but also their appropriate application to model real-world business logic. That's all from me. Thank you.